Have you ever just felt completely buried?
Yeah.
Looking at a huge pile of documents or maybe research papers, just tons of text, and thinking, I wish I could just know what's important here.
Oh, absolutely. It's like this constant flood, isn't it? Information overload is definitely real.
It really is. Trying to pull out the key stuff quickly without spending hours reading every single word, it feels almost impossible sometimes.
Yeah, that's the big challenge for pretty much everyone these days. Finding info isn't the hard part anymore. It's making sense of it, figuring out what actually matters.
Exactly. And that's really our mission for this deep dive. We're going to get into something pretty fascinating, a custom AI engine. Think of it as your personal information assistant built with some really powerful tools, FastAPI, Hugging Face models. Its whole job, just cut through all that noise and give you the insights you need fast.
Yeah, we're basically going under the hood, looking at the actual code, the architecture of this thing, how it takes a document, chews on it, answers your questions about it, gives you a summary.
And stays ready to go.
Right, exactly. And making sure it's always there, always ready. It's a really practical look at how AI can actually work for you, for pulling information together quickly. Not just theory, but how it's really built.
And the cool thing is, what we're talking about today isn't just general ideas. It comes straight from looking at the code that makes an engine like this tick.
Right. So we're not just talking concepts. We're talking about the nuts and bolts, how it's put together, the specific components, the design choices.
Down to the fundamental bits.
Precisely. And what's really driving this whole thing, the brains, if you will, are these powerful models from Hugging Face.
Hugging Face. They come up a lot in AI discussions.
They really do. They're a huge hub for open source machine learning, makes really advanced AI accessible, and these models are what let the engine actually sort of understand and work with text intelligently.
Okay, so when you say understand, it's not reading like a person, right?
Yeah.
How does it, process the words?
That's where embeddings come in. It uses something called Hugging Face embeddings, and specifically a model called All-Minil LM-L6v2.
All-Minil LM-L6-V2.
All-Minil LM-L6v2. Catchy name.
Huh. Yeah, they often are. But what it does is clever. It turns text words, sentences, chunks of text into numbers. Numerical representations. Yeah, think of it like giving every concept or piece of text a unique address in a massive multi-dimensional map of language. These are vectors.
So translating human language into math that computers get.
Exactly. And the reason that specific model, All-Minil LM-L6v2, is smart is because it's really efficient. It creates these detailed number representations without needing, a giant supercomputer.
So it's powerful but also practical.
That's the key. Good understanding, but runs fast. It's a great balance for real-world apps. Once everything's numbers, the computer can compare them, see how similar different pieces of text are based on how close their number addresses are.
Okay, so car and automobile would be close together on this map. Very close. And that's the foundation for how it finds relevant information, way beyond just matching keywords. It understands the meaning, somewhat.
Got it. That map idea helps. So it has this numerical grasp of the documents. How does it then answer a specific question I might ask? That seems like another leap.
Right. For question answering, it switches gears. It uses a different model, Deep Set Roberta-based Squad 2.
Okay.
This one's trained specifically on a big data set of questions and answers called Squad. So you give it some text, the context in your question.
And it finds the answer within that text.
Exactly. It's trained to pinpoint the precise snippet in the context that answers your question. It's pretty impressive. Like a laser finding the exact phrase.
Okay, cool. Yeah. And what about summarizing? If I don't have a specific question, just need the gist of a long report.
For that, yet another specialist model.
Yeah.
Facebook BART Large CNN.
BART.
Yep. It's known for being really good at taking long texts and crunching them down into shorter summaries while keeping the important bits, like a super fast editor.
So you've got one model for understanding, meaning via embeddings, one for question answering, one for summarizing.
Exactly. And the beauty of using Hugging Face is how these different tools can be managed. They have these things called pipelines.
Pipelines?
Yeah, they make it really easy to load and use the right model for the right job embeddings, Q&A, summarization, whatever. It keeps things modular and flexible. You can swap models in or out without rebuilding everything.
Like Lego bricks for AI tasks.
That's a great analogy, actually, yeah.
All right, let's shift to the structure holding all this together. FastAPI and the API endpoints. This is how you actually use the AI, right? make it do stuff.
Absolutely. FastAPI is the web framework. It's modern, really fast. It takes those AI models and wraps them up so you can talk to them using simple web requests.
So the AI isn't just code on a disk, it's a service you can call.
Exactly. It makes it accessible. Other programs can use it. You could potentially use it from a browser. It connects the AI power to the outside world.
Okay, so first things first, getting my documents into this AI brain. How does that happen?
That starts at the upload endpoint. You send your document file there.
Any kind of document. PDF. Word.
It tries to be flexible. It uses something called unstructured loader, which is designed to handle lots of different types. PDFs, Word docs, plain text, maybe even images with text eventually. It just tries to pull the text out.
Okay, it gets the text. But documents can be huge, right? You mentioned the models work best with smaller pieces.
You nailed it. That's a critical step. You can't just stuff a 100-page document into these models directly. It uses a tool called recursive character text splitter.
Sounds technical.
It is, but the idea is simple. Break the big document into smaller overlapping chunks, like maybe 500 characters per chunk.
Overlapping. Why overlap?
Good question. The overlap, say, 100 characters is crucial. It makes sure you don't accidentally cut off an important sentence or idea right in the middle when you split the chunks. The context flows across the boundary.
Smart. Avoids losing meaning at the edges.
Exactly. This careful splitting prepares the text so the AI models can process it effectively and accurately.
And these chunks are what get turned into those embeddings using the all-MINL-LM L6v2 model.
Precisely. Each chunk gets its numerical fingerprint, its vector embedding.
And where do all these numbers go?
They get stored in a special kind of database, a vector database. This engine uses FAI.
FAISS.
Yeah, it stands for Facebook AI Similarity Search. It's not just storage. It's a library that's incredibly optimized for finding similar vectors really fast, even with millions or billions of them.
So when I ask a question later, this FAISS thing is how it finds the relevant chunks super quickly.
That's its job. It makes the search part almost instantaneous. The engine checks if this vector but exists, loads it, and adds the new chunks. If not, it creates one and saves it.
Okay, uploading, splitting, embedding, storing. That sounds like it could take a while, especially if lots of documents are coming in.
It could bog down, yeah. But the engineers thought about that. It uses things like thread pool executor and Asyncio.
More technical terms.
Yeah. But basically, it means the system can handle multiple uploads and processing steps at the same time without getting stuck waiting. It does things concurrently, non-blockingly.
So it stays responsive even under load.
That's the goal. Smooth experience. And importantly, access to upload is protected. You see secure token 123 in the code.
Yeah.
That's a placeholder, obviously, but it represents authentication, making sure only authorized users can add documents, security first.
Right. Makes sense. Okay, so the knowledge is in. How do I ask my question?
For that, you use the query endpoint. Send your question there.
And I guess my question also gets turned into an embedding.
You got it. Using the same all-MINL LML6v2 model, now you have a numerical representation of your question.
And it compares that to all the document chunk embeddings in FAISS. Finds the closest matches.
Exactly. It uses FAISS and what's called a retriever. This one is set up to find the top K3 most similar document chunk.
But why 3?
It's usually a good balance. Enough context for the Q&A model, but not so much that it gets confusing or slow. It finds the 3 text chunks whose meaning is closest to your question's meaning.
And those 3 chunks are the context you mentioned earlier.
Perfect. Those 3 chunks become the context. That context plus your original question gets fed into the deep Cetraberta Base Squad 2 question answering model.
And that model finds the specific answer within those chunks.
Precisely. It extracts the answer from the context you just gave it. And again, secure token needed here too.
Okay, what about the summaries? If I just want the overview of report-final.pdf.
That's the summary endpoint. You tell it the file name you uploaded.
And it pulls up the chunks for that file.
Yep. It grabs the relevant chunks, stitches them together into a longer text, maybe up to 10,000 characters here.
Oh, that's quite a bit.
Yeah, gives the summarizer enough to work with. Then it passes that long text to the Facebook BART Large CN model.
The summarizer model we talked about.
That's the one. And you can even control how long you want the summary to be.
Oh.
You can specify a max length and a min length when you call the endpoint. So you can ask for a really short summary or something a bit more detailed.
That's really handy. Tailor it to what I need.
Exactly. And yes, needs the secure token as well. Keep things locked down.
Let's peek a bit more under the hood. Does this need a monster computer to run? All these AI models sound heavy.
Well, it's clever about that. It checks if you have a GPU, a graphics card, using torch.cuda.i is available.
Why graphics card?
GPUs are actually really good at the kind of math these AI models do, much faster than a regular CPU for many tasks.
Ah.
So if it finds a GPU, it uses it to speed things up. If not, no problem. It just runs on the CPU. It adapts.
Flexible. Runs on different hardware.
Yep, makes it more accessible. And it keeps things organized, too. Uploaded files go in one folder, uploaded docs, the vector database in another, vector B, the models themselves in .models. Clean structure.
Helps keep track of everything.
Yeah.
What if I upload two files named notes.txt? Does one overwrite the other?
Good point. No, it avoids that. When you upload a file, it generates a unique ID for it using uided.uided4.
A what now?
A UUEU. Universally unique identifier. It's basically a super long random string of characters that's guaranteed to be unique. So every uploaded file gets its own unique internal name, preventing any clashes.
Simple but effective.
Very. It avoids a lot of potential headaches.
Okay, one last endpoint mentioned. Health. Sounds simple, but why is it important?
Oh, it's critical in real-world systems. The health endpoint is like the system's pulse check.
Post-check.
Yeah. External tools like monitoring systems or load balancers constantly ping this endpoint. If the engine is running okay, it just instantly replies with something simple like status.
But it's like, I'm alive.
Pretty much.
Yeah.
If that check fails or takes too long, the monitoring system knows something's wrong and can raise an alarm or try to restart it. It ensures the service is actually up and responsive, minimizes downtime.
So it's key for reliability, making sure the AI navigator is actually there when you need it.
Exactly. Essential for any service you depend on.
Okay, so wrapping this all up, we've really dug into how this AI engine works. It takes documents, uses clever Hugging Face models like All-Middle LM for embeddings, Roberta for Q&A, BART for summaries.
Breaks them down, turns them into numbers, stores them efficiently in FAISS.
And uses FastAPI to make all that power accessible through simple API calls like upload, query, summary.
And it's built smart, checking for GPUs, using unique IDs, having that health check for reliability. It's a really well thought out system for tackling information overload.
It really shows how you can take these complex AI pieces and fit them together into something practical that, solves a real problem.
Definitely. By breaking it down, splitting, embedding, retrieving, answering, summarizing it, turns this massive challenge into manageable steps. It's a clear path to getting value out of your documents quickly.
And understanding this stuff really empowers you, doesn't it? You can see how you could use tools like this to just cut through the noise, learn faster, manage information better, save so much time, and frankly, frustration.
It really does.
Yeah.
And that leads to maybe a final thought for you, the listener, to chew on.
Yeah.
How could you integrate something like this, these modular AI engines, for specific tasks like document processing into your world, your workflows, your research, your business? I mean, just imagine if every document, every report, every paper you came across was instantly searchable in a deep way, instantly summarizable. What new questions could you ask then? What connections could you make if that information overload just wasn't an obstacle anymore?